Hello. As promised, I'm going to go over a couple questions on last night's homework that people had questions with. Just a couple on the back. So if you've got your homework from yesterday, 12-2, if you want to flip over to the back. One that most people asked about was 25, and I was actually impressed with how many people did get 25 yesterday. This tends to be a tough one for people. So let's just talk about that. Evaluate this long expression. So you've got 3 logs in here with this random 2. Basically what you want to do is evaluate each piece of this separately. And if you need to set these equal to x and exponentiate, you can. I saw some people doing that. Log base 5 of 125 equals x, exponentiate by 5, things like that. It's quicker if you remember what a log means. It means what number goes on this base of 5 to get 125. So think about that. 5 to what power gives you 125? 3. So this is 3. Similarly, 10 to what power gives you 1,000? 10 squared is 100, 10 cubes is 1,000. So that's a 3. This 2 I'm just going to bring down. That's just a random 2 that's being multiplied. Log base 2 of 32. What power goes on 2 to give you 32? 2 to what power gives you 32? 2 cubed is 8. 2 to the 4th is 16. It's 2 to the 5th. So 3 times 3 is 9. 9 times 2 is 18. And 18 times 5 is 90. So that's how the answer here is getting 90 if you had issues. Okay? Okay. The other one that I said that I would go over was 26c. Given log base, or f of x equals log base 1/4 of x, find f of the cube root of 16. A little ugly. So if I do log base 1/4 of the cube root of 16, if I plug that in, obviously pretty ugly. I'd probably set that equal to x to evaluate it, because this is saying 1/4 to what power gives you the cube root of 16. Maybe some of you can figure that out. Most of you, I'd say set equal to x, exponentiate by 1/4. So I would have the cube root of 16 equals 1/4 to the x. Now the numbers you want to zero in on here are 16 and 4. What's the common base with 16 and 4? You could use 2 or 4. Let's use 4. And this would just be 4 to the what power? Well, 4 to the first would be 4, so 1/4 is 4 to the negative first. Over here, you'd have the cube root of 16, which is just 4 squared. But remember what that cube root means. Now, this is the root. That's the power. So this is 4 to the power of 2 with a root of 3. 4 to the 2/3 equals 4 to the negative x. So negative x equals 2/3. And that's how I get that x is a negative 2/3. All right. Those are the only questions that I saw. If you want to go over anything else, let me know. For today, let's start with a warm-up. So maybe jot these answers down somewhere. Pause the video, try these, and for the evaluate section, see if you can evaluate these without setting them equal to x. Try to just look at them and saying what goes on this base to get that power for all of those, okay? All right, so give that a shot, and when you're ready to hit play, check your answers. Okay, so I'm assuming that you've had a chance to try this. So solve for y in terms of x. These were from day 1. If I want to get y alone, I got to get rid of this 9. What do? I don't divide, because that's the whole purpose of this unit. If I want to get rid of the base of an exponent, I take the log base. So we're going to do log base 9. Log base 9 of x equals log base 9 of 9 to the y. That cancels. So there's y alone. We'll have y equals log base 9 of x. Same over here. What are you going to do for b? You're going to take log base pi. So log base pi of x equals log base pi of pi to the y. Those cancel. So now I have y equals log base pi of x. Good. Okay, so now for the evaluating. By the way, your random fact, Alaska has the highest percentage of people who walk to work. Huh, interesting. 3 to what power gives you 9? 2, 3 squared. How about B? So if it was just 8, what would it be? 2 to what power gives you 8? 2 to the third gives you 8. Since it's 1 8, what do you think your answer should be? It's a negative exponent. 2 to the negative 3 gives you 1/8. How about C? What exponent goes on 4 to get 2? When you're getting smaller with exponents, you kind of have to think in terms of roots. So the square root of 4 is 2. So square root means to the 1/2 power. Okay, so now all of these. 7 to what power gives you 1? 7 to the 0 power gives you 1. 14 to the what power gives you 1? Well, anything to the 0 power gives you 1. So we talked about this yesterday, but remember that no matter what the base is, if there's a 1 inside, whatever the base is raised to the 0 power is going to equal 1. So those are all 0. Okay? Okay. Let's go over to your notes for the day. So this is day 3. We're talking about properties of logs today. And if I was in class, what I would do is I would have you fill out this chart. I would go around individual person by person and say, give me that answer, give me that answer, give me that answer. I'll do the top row for you. Then I want you to pause the video and fill out the rest of this chart. Skip over this because we'll come up with that. And then fill out this whole chart. Okay, so this is just practice evaluating. Log base 2 of 4, what's that equal to? Well, 2 squared equals 4. It's that same as the warm-up. What base goes on, or what exponent goes on the base of 2 to give you 4? And it's 2 squared. What's this one going to be? 3. 2 cubed is 8. This one is just adding those two values together. So log base 2 of 4, we know that's 2. Log base 2 of 8, we know that's 3. 2 plus 3 is 5. And log base 2 of 32, 2 raised to what power would give you 32? 2 to the 5th again. Okay, so don't worry so much about the column headings. I'll come to that in a second. I want you to pause the video, get practice evaluating. So fill out the rest of this table, then skip over this, and then fill out all of this table. And then I'll go show you the answers. Okay, so hit pause, try that now, do it really. Okay, so if you're watching this, that means you finished all of the charts. If you haven't and you're trying to get one by me, don't do that because that's annoying. So pause it and try it. But assuming you've done them all, here's what the answer should be. That should be 1. 3 to the first is 3. That should be 2. 3 squared is 9. 1 plus 2 is 3. And 3 cubed is 27. Okay? 4 to the 4th is 1. Or 4 to the first is 4, so that's why that's 1. 4 squared is 16, so that's why that's 2. 1 plus 2 is 3 again. And 4 to the third power, 4 cubed is 64, so that's 3 also. All right, going down to these ones. 2 to the 4th is 16, so that should have been 4. 2 to the first is 2, so that should be 1. 4 minus 1 is 3. And 2 to the third is 8. Maybe you had to try this one on your calculator. 3 to the 4th power is 81. 3 cubed is 27. 4 minus 3 is 1. And log base 3 of 3 would be 1 because 3 to the first is 1. Or 3 to the first is 3. 5 cubed is 125, so that's a 3. 5 to the first is 5. This is 3 minus 1, that's 2. And we know 5 squared is also 25. Okay, so let's see what we just found out. It's not a coincidence that these last two columns are the same. And look at the headings. If I have log base b of x plus log base b of y, that comes out to be the same as log base b of x times y. So look what that means. Log base b of 4 plus log base b of 8. The base is 2, so the base has to be the same, which they are. In all these cases, the bases are the same. The numbers inside, if there's 2 logs added, That's the same as 1 log with those numbers, x and y, multiplied. 4 times 8 is 32. 3 times 9 is 27. 4 times 16 is 64. So this is our first log rule. If I have log base b of x plus log base b of y, that's the same as log base b of x times y. So basically this rule says 2 logs added, I can smush that into 1 log with the stuff inside multiplied. They're always going to be the same. You can see that they're the same in the table. Works for whatever numbers you try. Now the important thing is the bases are the same. I couldn't have like log base 2 of one number and log base 3 of another number. That wouldn't work. The bases in all of these are always the same. Okay, so you're going to see the same type of thing down here. These last 2 columns are equal. Always get the same number. And what this is saying is if you have 2 different logs but the same base subtracted, you can smush that into 1 log with the numbers inside divided. 16 divided by 2, that's why this is an 8. 81 divided by 27 is 3. And 125 divided by 5 is 25. So the second rule is if you have 2 logs subtracted, log base b of x minus log base b of y, you can make that 1 log with the numbers inside divided. So 2 logs subtracted is the same as 1 log divided. Okay, over on the back, power property. Let's evaluate both of these. Log base 2 of 4 squared. Well, that's really just saying the log base 2 of 16. What would that be? 2 to the 4th power is 16. That's 4. This is 2 log base 2 of 4. Well, what's log base 2 of 4? What's just that piece? 2 squared is 4, so that's 2 times 2. Also 4. They're the same as well. So that means this expression is happening. And what's really happening is that, see this 2? Where was that in the left side? It's not the base, it's the exponent actually. So that exponent's getting pulled out front. And that's going to be allowed to do as well. If you have an exponent inside a log, it's always the same as pulling that exponent out front and then having the log left over. So that's called the power rule. If I've got log base b of x to the n power, we can bring that n out front, say it's n times log base b of x. Okay, so those 3 things I showed you are called the 3 log properties. And today we're just going to get practice using those. You're going to see why we have them in a couple days. But for now, there's kind of 2 major types of questions, maybe 3. Expand using properties of logarithms and simplify logs when possible. Now, one thing I'm going to keep saying throughout this is think big picture. And when I say that, we have 3 options. 2 logs added, 2 logs divided, or powers. So when I say big picture, like look at log base 5 of a cubed over bc, I want to say, would you say everything inside this log is being raised to a power? Is everything being multiplied? Or is everything being divided? That's the big picture. What would you say? Hopefully you're saying divided. Only the a is being raised to the power. Only the b and c are being multiplied, but the entire stuff is being divided. So that's what I have to take care of first. And this is me using this rule. I want to expand it. So I'm on the right side right now. 1 log divided becomes the thing on top subtracted from the thing on the bottom. So this is going to look like log base 5. 1 log divided becomes 2 logs subtracted. Log base 5 of a cubed minus log base 5 of bc. Okay, now work these separately. This first log, is everything being multiplied, divided, or raised to a power? Obviously, the only thing that's happening is being raised to the power. And I can use this rule. I can bring that power out front. So this first one's going to be 3 log base 5 of a minus, now what's being happened to this one? Everything inside the log is being multiplied. So 1 log multiplied can split up into 2 logs added. Log base 5 of b plus log base 5 of c. Now, anyone having any thoughts about something that's wrong about how that's written right now? Well, it's kind of a subtle thing, but this whole second log was subtracted. So we need parentheses around all of this because this expression, this entire expression, has to be subtracted still. So what that's going to mean for us is we need to distribute that negative through. And my final answer is going to be 3 log base 5 of a minus log base 5 of b minus log base 5 of c. And that's expanded as much as you can because there's no other property that I can pull out. Okay, let's try b. Think big picture. Is everything being multiplied? Is everything being divided? Or is everything being raised to the same power? It's same in there. There is stuff being raised to powers, top and bottom, but they're not the same power. So hopefully you're thinking, again, everything's being divided. So how's that going to split up? It's going to be the log. Notice there's no base. We'll talk about that some other day. It's going to be the log of 100 x squared minus the log of y cubed. Okay. Go further. Think big pictures. Everything being multiplied, or is everything being raised to the power? You might be tempted to pull that 2 out front, but the 100's being raised to the first power. Everything's not being raised to the second power. Everything inside it is being multiplied. So this needs to split up into log of 100 plus log of x squared. What can I do with this one? Everything's being raised to a power. We can bring that out front. Minus 3 log of y. All right. Now I did say evaluate logs when possible. Log of 100. Well, if there's no base, this is called the natural logarithm. Log means log base 10. Now they use 10 because we have a 10 counting system. Think of the ones place, the tens place, the hundreds place. So the common logarithm, or the common logarithm is base 10. So if there's no base written, assume 10. So knowing that, what would be log of 100? Log base 10 of 100. 10 squared. So that's a 2. Plus, here I can still bring that 2 out front. 2 log x minus 3 log y. There you go. Expand it as much as possible. Okay, now C. I've got a cube root in 3, or in C. What do you think about that? We don't have any root rules, but I do have a power rule, and the cube root means the same as what power? The 1/3 power. So this is going to be the log of y squared over z. Think of it as raised to the 1/3. So now think big picture. Is everything being multiplied, divided, or raised to a power? Well, now everything is being raised to that power. So I would start with bringing the 1/3 out front. 1/3 log of y squared over z. Now what's happening? Is everything being multiplied, divided, or raised to a power? Only the y is being raised to the power. It's all being divided, so I have to subtract. So it's going to be 1/3 log of y squared minus log of z. And again, what's wrong with how I wrote it? That 1/3 was in front of the whole log originally, so it has to be in front of both pieces when I expand it. So put an extra set of parentheses. All right, now the only other thing I can do inside is I can pull this 2 out front. So I'm going to have 1/3 times 2 log of y minus log of z. And then for my final answer, let's distribute that 1/3 through. So 1/3 times 2 is 2/3 log y minus 1/3 log z. Okay, now that one got a little bit annoying with that 1/3 out front, and it's really easy to forget those parentheses. So another option that I might suggest you do when it looks like that is what we used to do, distribute that 1/3 exponent. We could have said this was log of y to the 2/3 over z to the 1/3. And now is everything being multiplied, divided, or raised to the same power? I would say everything's being divided. So I would have started with log of y to the 2/3 minus log of z to the 1/3. And then just pull these powers out front. 2/3 log of y minus 1/3 log of z. You notice I get to that answer a little bit quicker. So it might be to your advantage to still distribute exponents. You don't have to worry about the parentheses if you do that. Just something to think about. So knowing that, in D, how would you want to think of that square root? You'd want to think of this as log base 2 of x to the 7th, y to the 3rd, all raised to the 1/2. Okay? And I could go like that, bring the 1/2 out front, but I think it might make more sense to distribute that. So this is log base 2 of x to the 7/2, y to the 3/2. Okay, now let's start using log properties. Everything being multiplied, divided, or raised to the same power. Everything's being multiplied. So 1 log multiplied becomes 2 logs added. So log base 2 of x to the 7/2 plus log base 2 of y to the 3/2. And then I can use the power rule. So I'm going to have 7/2 log base 2 of x plus 3/2 log base 2 of y. Okay, so that's expanding. On the next page, we want to condense. So I'm going to flip to the next page now. Use the properties of logs to write into an equivalent form containing a single log. Now notice, none of those log properties I did at the beginning have numbers in front of the logs. 2 logs subtracted, they don't have numbers out front. So I need to generally use this power rule first. If there's numbers out front, bring them in as exponents. So here I have a 1/2 out front and I have a 2 out front. Before you start condensing, bring those in. So this is going to be log base 3 of x plus log base 3 of y to the 1/2 plus log base 3 of z squared. Now, I can say that this is the same as log base 3 of x plus log base 3 of radical y plus log base 3 of z squared. It's probably better to think of it that way. And now I've got 3 logs added. So I've got the 2 logs added equals 1 log multiplied situation. You can expand that to 3 logs. So if 3 logs are added, we can just make this 1 log, log base 3, with everything inside it multiplied. So it'd be x times radical y times z squared. So your goal here is to have 1 log written in your answer. If you have log written more than once with a condensed problem, you didn't do it right. Okay, now this one has an extra set of parentheses. So for this one, I know I just told you to put the exponents in first. Why don't you start inside the parentheses like PEMDAS? I've got 2 logs subtracted. What's that going to become? The 2's out front. 2 logs subtracted becomes 1 log, so write log 1 time. And then inside it, you should have the two things divided. X over 3y. Okay, now what happens with that 2? That goes up. So this is going to be log of x over 3y squared, which technically is okay because you're condensed. If it's a multiple choice, they might write it as log of distributed x squared over, what would the bottom be? Not 3y squared, 9y squared. So technically either of those are okay. The last answer is probably the best. Okay. C. Only difference with C is we've got numbers everywhere. Where would you start? Well, we've got 2 logs added, but there's a number out front, so that number out front has to go in as an exponent. So I would start by saying this is log base 2 of 64 to the 1/2 plus log base 2 of 1/4. Now, what is 64 to the 1/2? That means the same as log base 2 of the square root of 64 plus log base 2 of 1/4. So let's do some evaluating. What's the square root of 64? 8. So log base 2 of 8 plus log base 2 of 1/4. Okay, so now I've got 2 logs added. If I want to use my log properties, what's that going to become? 1 log multiplied. So log base 2 of 8 times 1/4, which is 8 times 1/4 is 8 divided by 4. It's log base 2 of 2, which we know would work out to be 1. 2 to the first power is 2. Okay. Now notice you could have gotten that from this step. What's log base 2 of 8? That's 3. What's log base 2 of 1/4? If it was just 4, it'd be squared. So this is 1/4, that's negative 2. 3 minus 2, 1. Check. Same thing we got at the end. Okay. Last section. These give people some trouble sometimes. If log of x is r, log of y is s, and log of z is t, expressed in terms of r, s, and t. So basically you have to use log properties so that you only see log x's, log y's, and log z's. So you need to expand as much as possible. And then we got one final step of just subbing in what those actually are. So if you were going to expand this, just like I did on the last page, what would we do first? We'd want to think of the 4th root as 1/4 power. This is y over z, all raised to the 1/4. And I could bring the 1/4 out front, but then again, you got those parentheses you have to deal with. So I would distribute that 1/4 and say this is log of y to the 1/4 over z to the 1/4. And then when you have 1 log divided, that becomes 2 logs subtracted. So log of y to the 1/4 minus log of z to the 1/4. And that's not fully expanded yet. The mistake is some people are going to say this is s to the 1/4, t to the 1/4, but we can't sub in these r, s, and t's until it's just log x, just log y, and just log z. So you got to expand one more step. Make this 1/4 log y minus 1/4 log z. And now since log y is s, this piece here is s. So I'd have 1/4 s minus, and similarly, since log z is t, this is minus 1/4 t. So there I wrote my expression in terms of s's and t's. Okay, one more. Would you say everything's being multiplied, divided, or raised to a power? Hopefully you're thinking they're all being multiplied. So 1 log multiplied splits up into 2 logs, or in this case multiple logs, 3 logs added. So it's going to be log of x plus log of y squared plus log of z cubed. And again, don't fall into the trap of writing s squared here. We got to bring that 2 out front. We got to bring that 3 out front. So this is log of x plus 2 log of y plus 3 log of z. Log of x is r, log of y is s, log of z is t. So your final answer should be r plus 2s plus 3t. And you have an expression written in terms of r, s, and t. Okay, so that last section, just think of it as one extra step of a substitution. Otherwise, it's the exact same as those first type examples we did where we expanded. All right, so that is the end of the notes. Go ahead and try homework 12-3, unit 12, day 3. Check answers on the blue sheet, and let me know if there's any questions you would like me to go over tomorrow. Good luck.